Hi, and welcome to Allen High School's discussion of acid and base chemistry at the APIB HL1 level. We're doing the last part of our little 4-beaker experiment, and this time we're going to add strong base to a weak acid. And I used calcium hydroxide, and we have acetic acid. DSE, remember doc saves everyone. We did add volume to volume. If you have volume to volume, you have to do a dilution. So for our calcium hydroxide, I have 25 times 0.023 is equal to 75 times the new molarity. And for the calcium hydroxide, I get 7.67 times 10 to the minus 3. I'm going to do the same thing for my acetic acid. Some of you can tell already by the number I picked where we're going with this. So my molarity is 1.53 times 10 to the minus 2, and no calcium acetate. Now, I've got to subtract 6.73 times 10 to the minus 3. And that same amount here, but don't forget, this time we actually have a mole ratio. We've got a mole ratio of 2 to 1. And then plus 7.67 times 10 to the minus 3. Now, this is a complete neutralization. We did not make a buffer. To have a buffer solution, you have to have some of its weak, and I hope you recognize that acetate as the conjugate base. You need to learn to do that. If you don't, you won't realize what we have here. So if this is my molarity of calcium acetate, I'm going to multiply this. I have 2 moles of acetate ion for every 1 mole of calcium acetate. Now, I'm not telling you that this is the fastest way to do these problems, but it's the method that is much less likely to get you lost. So what we have here is 1.53 times 10 to the minus 2 molar solution of a base, conjugate base, O2 minus. So if you don't recognize that as the conjugate, you might not realize what our equilibrium is. And, it's kind of like where's Waldo when you're searching for your equilibrium. Sometimes it's not always as intuitive. And this is as hard as these questions get. So if you're following me right now, you're doing really, really well. So we're going to take that concentration of acetate. Because it's a weak conjugate base, we have to set up an equilibrium. And I notice I have this wrong here, so I'm just going to fix this for us so that I don't have to restart my video. So give me just a second. I forgot to edit a few things here. And so if this is a conjugate base, we're going to get hydroxide here. So that's our hydroxide. So we have acetate, which is a base, and what bases do best is take an H and a plus, and when it does, it's going to form a little bit of that acetic acid left. So back from remember the stop of our stoichiometry becomes our initial of our equilibrium. None of this, none of that. We do not have a buffer solution here. This is a base, so I'm going to put minus B plus B plus B. 1.5 times 10 to the minus 3. Whoops, getting jumpy on me. Minus B and B and B. We're going to neglect that one, even though it's a little, well, this time it's not so borderline, actually. Now, here's the problem. The issue with this one is we were given the Ka for acetic acid. The Ka for acetic acid is 1.8 times 10 to the minus fifth. But this is a Kb question. It's hydroxide times the acetic acid HC2H3O2 over my acetate. So that's kind of the second part of this. It's a little tricky. The first part is recognizing what the equilibrium is, and the second part, and I actually just plugged that number in, that's the C2H3O2, right? Minus. The second part of it is recognizing that Kb times Ka is equal to Kw, and Kw at 25 degrees Celsius, it changes with temperature, so be careful. At 25 degrees Celsius, it's 1 times 10 to the minus 14th. So my Kb is equal to 1 times 10 to the minus 14th over 1.8 times 10 to the minus 5th. So now I can substitute in. If you do that math, you get 5.56 times 10 to the minus 10 is going to be b squared. Now I'm hoping it's all downhill from here. If we solve for b, please, please, please double check my algebra. You know, every once in a while we all finger slip on those calculators. POH equal to 5.54. Let's make sure it's at least logical. It's a base. I expect my pH to be above 7. And this isn't a very strong base. Minus 10 is pretty weak base. So I don't expect it to be a whole lot above 7. And indeed it's not. The pH ends up being 8.46. Now, if you calculated your percent ionization, I'll let you do that. If you do your percent ionization, I came up with 0.02%. It's basic, but not very basic. Okay, tiny percent ionization, but still not negligible. I mean, you know, it's got 10 times more OH plus. So it's significant, but small. Okay, so until I see you in class, this is signing off.